Welcome to solverfy.
Okay, in this exercise we need to count all the positive integers that are less than 1000 that are not divisible by 4 or 6. Okay, so in this case we need to use the inclusion-exclusion principle. The idea here is that we know that I'm going to put some notation here. First, n sub 4 are going to be the number of positive integers divisible by 4. N sub 6 is going to be the number of positive integers, I'm going to denote with the z and the plus sign, that are divisible by 6. And 4 or 6, okay, is a number of positive integers that are divisible by 4 or divisible by 6. Okay, and one last notation that we need for this exercise is 4 and 6. So this is just the number of positive integers that are divisible by 4 and divisible by 6. So in this exercise we need to count the number of positive integers that are not divisible by 4 or 6. Okay, so this translates to negate, to technically minus. We need to take, this is going to be equals to take the total, all the possibilities that I forgot to put here, all the positive integers less than 1000. Okay, minus those numbers that are divisible by 4 or 6. Okay, if we take all the possible integers and then we eliminate all the integers that are divisible by 4 or 6, the remaining set is going to be all the numbers that are not divisible by 4 or 6. Okay, so that's the idea of this exclusion principle. Okay, great. So the point is that, well, t is really easy. We have all the positive integers less than 1000. That means that we have 999. Okay, so those are all the integers on that interval. Oh, sorry, here is, yeah, is not less than 1000, is less than 1 million. Okay, less than 1 million. So in this case is yes, 999,999. Okay, and the number, all the integers that are divisible by 4 or 6 is going to be all those positive integers divisible by 4 plus all those that are divisible by 6 minus the intersection, means those that are divisible by 4 and 6. Why this subtraction? Well, because in this part, in the summation, we're counting twice the intersection, so we need to eliminate one of those intersections. So if we replace this onto this part of the formula, we obtain that the number of positive integers that are not divisible by 4 or 6, it's going to be equals to 999,999 minus here all those that are divisible by 4 minus all those that are divisible by 6 and plus the intersection. Okay, so we need to calculate that. So it's not that hard because the numbers the positive integers that are divisible by 4, it's going to be taking the upper bound, okay, of this interval that is 999,999 divided by 4, and we need to take the floor function to count how many integers we have on that are divisible by 4. So this is equals to 249,999, and we need to repeat the same for n6. So this case we have 999,999 divided by 6. Here the floor function, and the result is 166,666. And the last is the intersection. All those positive integers that are divisible by 4 and 6. So in this case, we need to take the 999,999 divided by the least common multiple between these two numbers, 4 and 6. And the least common multiple is, in this case, is 12. So this is 999 divided by 12. And this results into 83,333. Okay, so we have all the values that we need to replace in our formula and have our result. So the result, all those positive integers that are not divisible by 4 or 6, it's going to be equal to 999,999 minus 249,999 minus 166,666 and plus 83,333. And the solution for this case is that the numbers that are not divisible by 4 or 6 are 666,667